Good day guys, welcome back to Wiki Science YouTube channel. In this video we'll be talking about how to solve questions dealing with convex mirror and concave lens. In this case now, we'll be looking at the nature of image that is formed by these two mirror and lens, in the sense that both of them can as well be called diverging mirror and diverging lens in respective ways. So in this case now, it means that a concave lens can also be called a diverging lens, as well you have a convex mirror can also be called a diverging mirror. But this is important thing for you to know, that irrespective of the position where the object is placed, the image formed is usually virtual, erect or upright, and at the same time diminished. Always diminished. That is, it cannot produce magnified or enlarged image. Now in this case now, there are different formulas which we have put together to ease your calculation in this aspect. The first one is that when you are dealing with calculation like this, you can use 1 over u minus 1 over v is equal to minus 1 over f. And at the same time, you can use that, maybe you are dealing with your multiplication now, you can use multiplication to be 1 minus v over f. And when you are dealing with your multiplication in respect to your object distance, you can say that your multiplication is equal to focal length over the focal length plus the object distance. Don't forget, when you have u to be your object distance, you have your u to be your object distance, you have your v to be your image distance, you have your f to be your focal length, we have your f to be your focal length, and we have our m to be the magnification. We have m to be the magnification. Do not forget, irrespective of the position where your object is placed using a diverging mirror or a diverging lens, the nature of image is usually, all the time, always, it is virtual, erect or upright, and it is always diminished. Erect or upright, and it is always diminished. Now we're going to treat UTME question taken from year 1991, question 29. We look at how we solve question on this aspect. Now the question states that which of the following correctly describe the image of an object 4 cm from a diverging lens of focal length 12 cm. The focal length is said to be 12 cm. So we have focal length to be 12 cm. Now here we have also the object is said to be 4 cm from a diverging lens. So we have the object distance to be 4 cm. The object distance is said to be 4 cm. So here now we need to determine the image distance. So and I've given you here that 1 over u minus 1 over v is equal to minus 1 over f. So here now we can use this because it contains all the parameters we are to use. So we have 1 over u is said to be 4 cm. Minus 1 over v is said to be unknown, that's what we're looking for, and we have it to be 1 over f minus 1 over f, and f is said to be 12 cm. In this aspect, we can take this to the other side, and we have it to be 1 over 4 minus, the minus comes here to become plus 1 over 12 is equal to, when I take this minus to the other side, it becomes plus likewise. So I have it to be 1 over v now equals, that is said to be 12, that is 3 plus 1, and we have it to be 1 over v is equal to 4 over 12, and at the same time you can have it that your v is equal to 12 over 4. So here we have v to be 3 cm. In as much our v, that is the image distance, is said to be 3 cm, we as well have it now that the nature of image is always said to be virtual. And virtual using a diverging lens means that the image is formed on the same side, that is formed in front, not behind. It's formed in front. This is because a lens uses the phenomenon of refraction, and the two sides of a lens is said to be reflective, unlike a mirror in which one side is reflective and the other side is polished. So when the image is formed on one side, it is not formed on the other side. In this case now, we say it is behind the mirror, but in the case of lens, the two sides are reflective. So when image is formed on one side, it can be taken to the other side. So when the object is at one side, the image can be formed on the other side. When the image is formed on the other side, we say it is view. But when it is formed on the same side as the object, we say it is virtual. So in this case now we say it is in front. So here we have it to be 3 centimeter in front. In front means on the same side. Here is another question taken from UTM past question 1979, question 32. And the question states that a concave lens of focal length 20 centimeter, focal length is said to be 20 centimeter, forms an image 1/2 the size of object. I've told you that whenever you have the number of times like that, it means your multiplication. So multiplication is said to be 1/2 the size of object. The object distance is said to be what? So here we're looking for the object distance. Now I've seen this question in the past question, and the way it has been solved in one I used, I realized that the question, the way it was solved, is totally wrong. Okay, now let's look at the way we're going to use this particular formula to get our answer clearly. Now we have that the focal length is 20, the multiplication is 1/2, and the object distance is unknown. So here we have your m to be equals to f over, that is f plus u. Your multiplication is said to be 1/2 is equal to focal length is said to be 20, and here you have the focal length to be 20 plus u. And in this aspect, we have that 20 plus u is equal to 40. U is equal to 40 minus 20, and we say u is equal to 20 centimeter. So here, the object distance is expected to be at 20 centimeter, meaning that the answer is none of the above, because here you have 100, 100/9, 60, 60/7, and you have none of the above. Here now we have the answer to be none of the above using this particular formula. So this is the particular formula we'll be using to test several questions related to diverging lens and diverging mirror, and as we always correct. So here now we have formula which is going to take you through short method in solving questions on diverging lens and diverging mirror. Share this video with your friends. Thank you very much. We'll see you next time.